Hello everybody. So I'm starting my stream tonight with the Raspberry Pi high quality camera, and I'm pretty excited about this. And this stream isn't going to be a super long stream for a couple of reasons. One of those reasons is I just got the camera like a day ago, 2 days ago. I don't know a lot about it, and I've kind of been out of the IoT world for a few years now, and I'm still just kind of ramping up and getting to know things. And also, I've got 2 chunks of fresh salmon that's just waiting to be barbecued tonight for dinner. So those are the reasons why this won't be a super long, like all-night stream. However, I will load up here a video. So I decided instead of having everybody sit and watch me kind of fumble with things, I pre-recorded a video yesterday that kind of shows how you put this together. So this is the Raspberry Pi high quality camera. I was put on a wait list. I want to say a month ago, something like that, maybe 2 months ago. It's been a while. On a wait list for this camera, and it's basically a high quality camera. It's 12.3 megapixels, which is pretty good for a Raspberry Pi camera. It's got a big sensor on it. It needs a lens, so I bought the camera, got on the waiting list, got the camera, got the lens, and just kind of started playing around with it a little bit yesterday, but haven't really done a lot with it. But I've got some cool stuff to show you folks about how to do it. And I have a video here that I will find, and let's roll tape. Okay, so here's what comes out of the box. And this is just a sensor with a ribbon on it. It has a little cap. There are a couple of interesting things about this. And that is a sensor inside there. And this is a pretty big sensor as far as digital cameras go in this price range, so it's really pretty cool. I hope it is. If not, so there are a couple of interesting things to note about this in this video. There's also a tripod mount in here, which I'm going to use. Now there's another interesting thing. There's an adjustment here where it goes in and out, and then you can take a little screwdriver and tighten down the screw. Now what that does is adjust focal length, so you can adjust in and out, kind of depending on where you want your lens to zoom. And I don't know how well you can see that, but it's this little twisty bobby here where you can adjust the focal length. So that is one of the things that I'll have to do in order to get the proper image focused in. So that's 2 really cool things about it. So I really appreciate the tripod mount and the focal adjustment. Now what I've done is I've purchased a cheap lens off of Amazon. This is a 35mm lens, and as you can see here, a little light input, some focal adjustment. This particular one was super cheap, and it also came with these little extenders. So I can adjust the focal length even more if I put this in here and then put my lens on it. So it's pretty cool. So I've got a couple of these. So what I'm going to do is figure out what I want to focus on, and I'm going to hook it up. Now this ribbon hooks in right here. I believe it'll also fit on here, which is where some of the older camera mounts were, but it goes on here. And so we're going to be hooking that up. And then I've got this little tiny mount, and I'm going to mount it. And I'm going to have all of this mounted up and pointing at something before the stream so that you guys don't have to sit there while I kind of fumble around with everything. I'm going to hook this thing into this Raspberry Pi. I'm going to put the lens on it. I'm going to focus the lens in on whatever it is that I decide to focus on, and then we're going to start playing with the images and the videos from there. But I just wanted to show what comes in the box, which is just this with a cap on it. Pretty simple. And like I said, this HD camera here is pretty HD. It's got some pretty good specs, and it looks like a pretty good sensor size. I have digital cameras here at home that have a smaller sensor than this, so I'm pretty excited about that. I'm excited to see what kind of quality it produces, and we'll get it set up. Okay, so to set this up, I'm going to plug the ribbon in. Pull off the lens cap. And I'll add my lens. Remember, the Raspberry Pi HD camera does not come with a lens, so you must find a CS or CS mount lens, which are generally found on CCTV cameras. And I will add my little tripod here, which is also not included in the kit. So I've got the Raspberry Pi hooked up here, out on a picnic table. I've got the lens hooked up. So I have the high quality camera going into the ribbon to the Raspberry Pi. I have the lens hooked up to it. I've got it sitting on a tripod. And then I have my laptop here showing a real-time image of it. That way I can do all of the adjustments with the lens and everything to get a clear image adjusted in. So let's get started. Okay, so I hope that video was at least somewhat helpful. I'm going to move some of my streaming stuff around. So I wanted to give out a shout out here. And I'm sorry, Matt, I don't know how to pronounce your last name because I haven't heard it, but it's Shernbeats, I'm not sure. But so Matt approached me on Twitter and when I was whining about Twitch muting my stream because I was using a no copyright stream on Spotify, and apparently one of the songs was indeed copyrighted or it triggered the algorithm, one or the other. Anyway, Matt kindly offered to let me use his stream here, and so you can go to his website. I've got it in the little scroller there below. And you can use these copyright-free songs, and it's pretty good music. I think he's done a really, really good job. So I just kind of wanted to give a shout out to him for that. And also another shout out. So tonight, my latest course is dropping, and that's the Go Standard Library. So the Go Standard Library provides a whole bunch of cool stuff with Go, things like file handling, string handling, formatting, all this kind of cool stuff. And I'm just releasing a 2-hour course on Pluralsight related to the Go Standard Library. And one of the reasons I'm really proud of this one is it's all done with Vim. So there isn't a whole lot of like visual code correction, all this kind of cool stuff. It's just very raw coding, and there's very few slides in the entire course. It's mostly just coding, and I tried to show off some of the common things that you would use the standard library for. So I tried to give a lot of real-world examples, a lot of raw code. So check it out. It's called the Go Standard Library. It'll be on Pluralsight tonight, and I'm pretty proud and excited about that. So let's go ahead and RDP into my Raspberry Pi that's sitting out on the bench. And let's just hope it's connected. Oh, it is connected. Okay. So I moved it. So yesterday I had it pointing in my front yard, and then I decided that it would be cooler to point it at my wood pile that I just got here. And let me close a couple windows here. So actually I kind of jumped to this capture here. I'll show you how you can do this capture. So I have a little shell script here called preview.sh, and this is what I use to dial in the camera. So I had to pull it out there outside, set it up, put the lens on, get the tripod, and do all kinds of zooming and light adjustments and things like that. This is how I do it. So you've got a little mod probe here, and of course you could load this module into the kernel permanently if you wanted to. And then this QV4L2. And so let's run that bash script here really quick. And this is a test bench for the camera. So this is pretty cool. So we've got it in as camera 0. There's a whole bunch of different controls on here. I haven't messed with all of them to see how they work, but you can change all the different controls and then like this, and you can see a live preview. So here's a live preview. I hope none of my neighbors do anything crazy while I'm showing you this video stream, but this is pointing at the wood pile and the field that I need to mow tomorrow and the road that I live on. So it's pretty good quality. And so this is a very cheap Amazon lens. So I basically bought this camera, and then I was like, it needs a lens. It needs a C or a CS lens, which are usually like CCTV cameras. And so I just picked one that was cheap that looked like it would be good. And this actually is a pretty clear picture. It looks about the same as the Ring cameras that I have around my house. So that's pretty cool. But I think experimenting with different lenses would probably be a good idea, especially if you're going to use this. So one of the things that I saw online when I was out searching were people that are using macro lenses on this particular camera to do pictures, and that's pretty cool. I don't think you could do it with this particular lens, but this isn't a bad picture for a $50 Raspberry Pi camera. It looks pretty good. It's got a decent color, decent contrast. You can see my little pile of wood. You can see the field detailed enough to see that I need to mow it again, which is, like I said, what I'm doing tomorrow. So let's do some cool stuff. So here's the shell script. Oh, this is a different shell script. Never mind. This is not the shell script that I was using earlier. This is a different one. So here's one where you could just make a shell script that grabs a date and then uses Raspi Still. So this thing, I didn't even install this Raspi Still program. So I think it just comes with the noob's image that I burned onto this particular Raspberry Pi, because I just went in and I was like, I started looking up things online. They're like, use Raspi Still. And I'm like, okay, I type it in. Oh, it's already there. So I think it's installed on the noob's image. And the only thing that I had to do was I had to hook up the camera, as I showed in the video. And then I had to go here to Raspberry Pi configuration, interfaces, enable camera. So one of the other things that I did just about an hour ago was I plugged in a temperature humidity sensor into the Raspberry Pi. So I didn't show that in the original setup video, but I plugged that in so that we could grab some of those values and maybe put them onto the camera. So I have my I2C enabled for that purpose, for that temperature and humidity sensor. I do not have anything other than I enabled SSH and VNC. That's how I'm connected to it right now. So this Raspberry Pi is literally sitting out on my picnic table, still within Wi-Fi range, but pointing out over my field. And so I'm just RDPing into it, which is a pretty good interface. It's pretty nice. So as I hooked up the camera, I just had to enable the camera in there, and then it's like ready to go with this Raspi Still thing. So let's just do a really quick thing here. Go into my projects folder. Camera. And we'll do Raspi Still. I can never type when people are watching. I don't know what it is. I'll fix that one of these days. This is your bare minimum for the Raspi Still program. It takes a still image, -O for output, test.jpg. So let's see what that looks like. And it takes a minute or so. I noticed some of the scripts that I wrote for testing earlier required a little bit of a delay, but here's our test.jpg, which is a pretty nice high resolution file. I mean, I have digital cameras sitting around my house that have smaller sensors than this $50 Raspberry Pi camera does. So this is pretty impressive. And when I did the focusing, I just kind of focused in on the wood there, just to make sure that was clear. But back here, this is also clear. You can see all these bushes. Earlier today, the county came by and mowed this, and you can actually see this in the picture where they mowed it. So this is a really detailed, clear picture. I feel like if you print it up, if you like had a 3D printer and you printed up a good enclosure for this camera in your Raspberry Pi, it would be a big bulky camera like the ones from the 90s. But it would actually probably be a pretty decent camera, you know, if you got a power supply hooked to it and things like that. This is the still picture that we just took. And we'll do it again for the heck of it. So what could you do with this Raspi Still program? You might be asking. You may not be asking, but... And there's our picture, and it's 12 megapixels. You can specify the size of output. We'll do that in a little bit, but you could let's talk about some of the ideas that you could do with this. You could make a security system that takes still frame pictures. That's some of the older security systems back in the day used to have these, where it would take a picture every minute or so, and you could write a bash script that would take a picture once a minute and maybe delete ones that are older than 30 minutes or something like that. And like, this is a good picture. I mean, if I were guarding my wood pile, I feel like this would get a pretty clear picture of somebody trying to steal wood, which, I mean, it's never happened before, but it would be kind of cool. And like I said, for the video part of it, the video resolution doesn't quite look as good, right, as the still pictures, but it's still not bad. My preview.sh must be somewhere else. I believe it is in my home directory. It is. So we'll just copy that over here so we can refer back to that whenever we need to. So this isn't quite as clear as a still picture, but it's pretty good. I mean, it's like I said, it's about the same as my Ring cameras are, which, you know, a Ring camera is $150. So if you start to do the math, it's probably a wash, but you could probably set up a Raspberry Pi with one of these cameras and a lens for roughly the same price as a Ring camera, and maybe push the videos up to the cloud. So let's look at how to record video with this device. And I'm going to have to bring up some notes here. So one of the things, if it's upside down, this is kind of cool. So we'll run Raspy Still again. And you can actually do a vertical flip and a horizontal flip with this thing. So if you needed to mount it in some weird way, you could do that. And this is what my wood pile would look like if it were in Australia. So you can do a vertical flip, horizontal flip. There's actually a ton of things. Like I said, I've only had this thing for 2 days, but when I was looking through some of the documentation for the Raspy Still, there's just a ton of really cool stuff that you can do with it. So let's run our little bash script here. This is our snapshot.sh, which I believe is in this folder. Yes. There's a pretty good delay on the warm up of the camera. And as you can see right there, we have a time-stamped image. So one of the things you could do, if you were so inclined, is create a cron job that calls the shell script once a minute, once every 5 minutes, whatever, and does these little time-stamped images. Which, if we look at them, they're just our Raspy Still images. So one of the things I'm going to do is load up my sensor, and I tested it earlier. It seemed to work pretty well, but this is actually the sensor.go from the last live stream I did on pulling data from the sensors with Go. And I just realized this now that I do not have a print statement in here. So let's put one in. Temperature. And we're just calling this humidity and temperature. Perfect. temperature. Now I tested this earlier and I think it's going to work. Let's hope it does. Now it's a little warm in Oregon today, so we should see. You can see where I ran my test pi earlier. There we go. 79.16 degrees, 46% humidity. So we know that it's working here. And if we wanted to, we could do a little formatting here. This is one of the things that I cover in my course on Pluralsight. Shameless plug time. String formatting. Very fresh in my mind right now. One of the things with these sensors, I'm using the AM2302 sensor, which is basically a DHT22 sensor that's enclosed. And they're great sensors at $10 a piece. There we go. But if you call them too many times, they will fail. And I've been using these things for years. And I've just noticed that if you hammer on them 9 times out of 10, they will work. But that one time it will say duration too long or bad reading. So it looks like we're at 78.98 degrees. So one of the things I have here is a Python file that does the same thing. There it is. Okay, so one of the things that I did earlier was I used the Adafruit DHT library, and it turns out that that's been deprecated. That's the one, if you go to jeremymorgan.com and you look up how to get a temperature from Raspberry Pi, I'm using that old library. So I decided to pull in the new library, and it's actually pretty sweet. If you can see this code here, this is all the code it requires to run it. So we'll do Python 3 temperature.py. And it is not working for whatever reason. But we know that the sensor is working, so we might have to do some stuff with this code. Let's write something that uses Python to pull... Oh, nope, my ADD is acting up again. I was going to show how to pull video from this thing really quick. So let's do that. That's raspberry-vid. And again, I think this is installed by default on the noobs installation. -O, and then you have to specify a frame rate, which we'll say a frame rate of 30 frames a second. I have no idea what frame rate this camera supports, by the way. And we'll do test H264. And what this will do is take a 10-second video. And my notes are not correct, which is fine. I probably just have the parameters out of order here. Perfect. And I'm going to look at the chat really quick. Holy moly. So I got 2 of some of the coolest people I know as friends of mine in the chat, Mr. Tom Massey and Richard Shaw. What would you... Let's see. And Tom Massey said grillin'. That's right. Let me show this again. On the camera. Gotta show it again. Fresh salmon. This stuff was caught yesterday. It's going to be so amazingly delicious. And then Richard Shaw says, Mr. Morgan, what would you suggest for a motion sensor package if one would want to set this up for a security camera or a trail cam? Since I know Mr. Richard Shaw, I know exactly what he's thinking. This would make a pretty good trail cam. Oh, and there's Corey Anderson, another awesome buddy of mine. It's pretty cool. Thanks for coming and watching my nonsense, you guys. So I have a motion sensor for a Raspberry Pi that I used one time about 3 years ago. It worked very well, actually. It worked like 3 feet away. But I don't really know what the best motion sensor is right now. The only thing I would be really concerned with a trail cam is just keeping it weatherproofed. So you'd want some kind of enclosure that gets rid of humidity, hopefully, and power supply. These Raspberry Pis use a lot of power. So the one that I have right now, I literally have an extension cord going across my yard because I didn't want it to die on the stream. So I've had battery supplies on them before, and I've had them last less than an hour. So I have an extension cord going across my yard, plugged into the table. It's crap, but it works. So I would be kind of worried for a trail cam about power supply and weatherproofing. Now let's look at our little video here. There's our video. And it actually worked. Even though I'm not really sure why it displays the file name on there. I think it displays the file name in the actual video. Let me check here again, but I mean, this could be VLC that's doing this right here, but I'm not really sure. So that's how you can capture video, and you can set a timeout on there and make it capture like an hour at a time. So another way, if you're designing a security system, would be to set a timeout, say 5 minutes, make it record video 5 minutes at a time, push it up to the cloud. You could push it up to an S3 host or something like that, I think fairly easily. And then you could do some kind of time-based delete, like after 24 hours, delete any files older than 24 hours. You could do all this stuff with Bash and probably be set pretty good. One of the things I did a few years ago at the fire department when we were having snow was I built this kooky little thing and I slapped it together. And this is, you know, anyone that's a developer knows how this goes. I slapped this together as like a proof of concept. Basically, I'm like, how about we just point a webcam out on the front apron of the fire department that uploads an image every 5 minutes and then deletes ones that are older than an hour. And then we can show the people of the town whether or not there's snow in town. Like if there's snow on our apron, then there's snow in town. And so I put this thing together and I used a Bash script to call the webcam program with some parameters, had it put in a date, write the date on the bottom, things like that. I kind of put it together, showed the chief, and he's like, that's amazing, we got to have it. And then I left it there and we used it for quite a while. And it was just literally a Bash script that called some Kermit scripts that uploaded it to the FTP. Yes, I used FTP for it and had some Kermit scripts upload to FTP. And then anybody could visit the website and click on live view and see the live view to see if there was snow on the ground. And yeah, it was a hokey little thing, but it worked great. People loved it. I'll probably do something similar to that in the future. So let's see what else I can show that is cool. We could do, let's capture this with Python. Again, full disclosure, I've been out of the IoT game for a long time. Just getting back into it and just figuring out how to work with some of these libraries and stuff. But let's see. So let's see. From time import sleep. So I have to put in a sleep function in there. For some reason, the camera just doesn't want to warm up and take the picture without it when we do it in Python. So do from, there we go, PyCamera. And let's see. And I can't find in my notes where, but I feel like I did have to install something with pip to do this. It might be pip install PyCamera. But I will do an actual like produced YouTube video on this and probably an article where we'll have all of the good details. PyCamera. And we'll create a new camera object. And this is pretty cool because this PyCamera library just kind of grabs camera 0 and does whatever with it. See, resolution. Let's say 1024 by 768. Yes, I have to look at my keyboard to type apparently today. And here we'll do camera start preview. Sleep 2. Sleep 1 might work, but sleep 2 definitely works. And then camera capture. And we'll just call this test.jpg. Or we'll call it test 2. That way we know it's something separate. Well, let's see how this runs. And yes, I probably should alias Python 3 to Python at some point. It's obviously not going away, but I haven't done it on this particular machine. And there's our image that we just grabbed. So this one, as you can see, is 1024 by 768. And it's a pretty decent looking image. It's kind of focused in there. And we can put an annotation on that. Camera dot. I'll see, there we go. Autocomplete. I was just bragging about my Go course and how we didn't use autocomplete, but here we are using autocomplete because I don't know this quite as well as I know the Go standard library, as it turns out. Annotate text. Oh, yeah, I think text size is probably a good thing to put in here. And I don't know what the input is for this particular one. We'll just roll with it and see what it does. I do know that we need to do a annotate background. Got it in my notes. There it is. And we got to set that bad boy to true. Okay, now we can run this and should put a little image on the screen. Ooh, not callable. That is false. That's probably because I put in these parens. So it does look like I'm trying to call a method. There we go. And Corey, who knows, who has forgotten more than I will ever know about electronics, tells me, I think you need root to access the GPIO pins. Try sudo in that Python script to read the temp. And I bet he is right. So I'm going to pull this text size out. Actually, let's pass the parameter in this way. We're not really calling a method. We're passing a parameter, so... Looks like this is going to be a lesson in Python data types. Okay, there we go. And we're creating test2.jpg. Look at that. This is a test in a fabulous font. Got it written up there. So I'm going to try to run that temperature one, and then we'll try to put the temperature into the image. Sudo Python 3. No module name board. That's interesting. Set line 17 to input. Let's dig into that. So it should be GPIO 17. And I'll see if I had anything in notes about this, because I know that I got this working earlier today. So import time board. Adafruit DHT. Could make sure that I declared this properly. DHT device. Gonna rely on that autocomplete again. DHT22, and then I should be passing in a pin. And it's board dot They're not going to help me. Looks the same to me. Okay, so I'll do lib GPIO D2. It is certainly installed. So maybe I need to install this under sudo. Install, let me check my notes and see what this was called. .dht. This is the one part of the demo that I didn't try. I just assumed it would work. That's what I get for assuming. Nope, it still does not like that. So, let's see if I forgot anything here. Temperature, DHT device. It is recognizing that part of the library. Let's try it. It's GPIO 17, but it's pin 11, so maybe I just have the pin wrong. Nope. What other thing could it be? Let's see, go run. Okay, the sensor is connected, and in my Go program, I have it set right there to GPIO 17. I know that's where it is. So I'm not really sure why. The temperature is not working. Let's try just running it with regular Python, but I'm pretty sure it's Python 3. Yeah. All right, I'll start Googling. I'm not too proud to Google. Let's see. Pip 3. I'll try the pip install again. This. GPIO D2. That should be. Pulse in message. Installed. Try sudo one more time with just Python. But I'm pretty sure this is a Python 3 library, so. Yeah, it doesn't like that. Let's just try some different pins here. All right. No Python module name board.
Looks like a different library, however. Board. Use Python 3. Now, I didn't have to install this earlier, but I'll install it now because I don't really care about installing crazy stuff. Let's install this library. Looks like it's already good to go. So I'll go to the next thing. We'll go right to the Adafruit website. Haven't installed Blinka yet. Yeah, we've installed Blinka. Whatever that is. Were you able to pass the Blinka test? Let's see if we can pass the Blinka test. Literally today is the very first time I use this CircuitPython library, so I know nothing about it. Actually, I don't even think I did this step right here, which is upgrading the setup tools. Nope. Looks like I did do that. And I did not check the I2C devices. Interesting. I'm not even really sure what an SPI device is, but I don't think this is an SPI device. I know that I did not install this library, so I'll do that really quick. And apparently it's already installed. We've got the Blinka library. All right, let's try to do this then. It still spit out a bunch of crap. It said digital I/O, okay. Yeah, that's just the printing stuff. That's interesting. That it's still choked there on line 16, which, yeah, I don't think this is an SPI device, so I don't think that part really even matters in our particular case. Digital I/O and I2C are good. So I may have to go back to the old way of doing that. Time import board does not work. Try one more Google result here. And this looks crazy. This is some terrible formatting. All right. Well, since I'm only doing this for an hour, we're going to have to fake it till we make it. I wonder if I could grab... Well, the grab image with the annotate text works. The sensor go dot works. How could we combine these in a smart way? Let's see. So I think we could do raspy still with annotations. There are a ton of options with this. AE? Or is it just A? Still, let's try dash A. Let's see what that produces. I don't see any annotations on that particular image. So I probably just don't know it well enough. So I'm going to go through this in reverse. Python 3 temperature.py. Unable to set line 17 to input. Make sure and close anything that might be using that GPIO. And I'm just going to go through this backwards. So runtime is error. It's going to print out the first error argument. Put this all in the same line here. This is our formatted output. Humidity, temperature, times whatever to make it Fahrenheit. And DHT device. Try DHT base, but it seems to be having a problem with this board input here. Pin and trig weight. Cool, I'll just make up some parameters for that then. Pin will be 11. I don't know what trig weight is. We'll just put in 1,000. We'll see how that goes. Oh, I see. So we'll do DHT 11. Pin 11 and 1,000, which could be 1,000 seconds for all I know. DHT 11 is not defined. So what is defined? It does not like my device definition there. That is a very odd parameter. Is it a string? Oh, it still doesn't get that pulse in message. Set to input. So, in the interest of saving time, we just have to pretend like we were able to grab that output. And here's what it would look like if this succeeded. Just keep running this thing. I'm wondering if I shouldn't just reboot this thing. Rebooting solves everything, right? Give it a minute here. This thing actually reboots fairly quick, so we might be back in business already. Not quite. There we go. Let's back up. We'll open up our Visual Studio Code again. This is the one we want. So Python 3 temperature.py. DHT device is not defined now. This is just a quick sanity check to make sure the camera is still working. Device is not defined because I commented it out. There's our temperature. So rebooting solves everything once again. So let's go ahead and pull this, and we're going to put this into our other one here. What was it? Grab image.py. Yeah. So we'll go to the top of this file, paste our Python in there, we'll import stuff. All right, for the grand finale demo, it's gotta work. Gotta work. So we'll actually just leave this printing. And we'll snag this and put put it right there. So theoretically, I'll even name this grand finale so that this demo works. Theoretically, this thing should try to grab the temperature, grab it, it'll print it out so that we can see it to see that it got a temperature, because it may not. And then it'll create a new PyCamera object, set it to this resolution, drop in this text, and annotate the background. So let's see if it works. Checksum did not validate. There we go. Let's open it up and see where we're at. Projects, camera. There isn't even a grand finale there. So I'm gonna say that it didn't work. Start preview, camera capture. Make sure we've got everything here. DHT device. Maybe. We'll uncomment the print. And I'm not running the right script. Well, that would make perfect sense, wouldn't it? GramImage.py. Thanks, Corey. Running the wrong script. Dummy. All right. Let's see if, there we go. There's our neat little temperature, humidity. Heck, we could even throw in the date in there if we wanted to. And this would just be the coolest camera image of my wood pile there. So maybe I should try to guard my wood pile and take advantage of the little camera here. And I'm not sure why I put a asterisk in there, but it should be a %. And both of these. If we get a yay without an error, we're good to go. There we go. That looks a little bit better. And since many of you are in Oregon, you can validate, many of you that are in the chat room here in Oregon, you can validate this temperature, which is beautiful and awesome. So I hope I've kind of showed a little bit about how you can use this thing. One of the coolest things I think is these little libraries that they ship with are pretty cool, but I really like this. There, where is it? This little V4L2 test bench. This thing is pretty cool. We'll bring that up again. You can see the wind blowing like crazy. This thing is pretty cool because you could go through and kind of mess with all these controls. Like we've got brightness, contrast. And I'm pretty sure, don't hold me to this, but I'm pretty sure that many of these parameters you can set with this PyGrab image. So you should be able to take this thing and say, well, I want this much contrast. Look at that beautiful wood pile. This much brightness. And then just kind of save these parameters. So when you're going back in here to the Python library, you could set all of those different parameters. And I'm sure you could still do it with like the Raspy Vid or the Raspy Still. I know they have a million parameters in there. So theoretically you could go in and get the camera looking exactly how you want, and then use it to set that to grab the stills, grab the videos, grab all that kind of stuff. It's pretty cool. So I'm definitely going to do a lot more with this when I know more about it. So I basically went on and kind of Googled a few things and slapped together a few things for this because I've only had it for a couple days, but I'm going to do some more intense stuff with it. And I guess there's an or an IR component to this camera, but I haven't even researched it or tried it out or anything else. So, but anyway, thank you everybody for coming onto my stream. So my stream schedule, the way I think I'm going to set it up for the next couple months is Tuesday, I'm going to do some like enterprise type stuff. So it'll probably be .NET, Blazor, some more enterprise stuff, maybe some Go stuff. And then Friday nights, I'm going to try to stream every Friday night, except it is summertime and we probably are going to take off for weekends, but I'm going to try to stream Friday nights just for fun stuff like this. Like there's no enterprise value to this. At least not any that I could really think of. This is just kind of goofing around. So I'm going to goof around with Linux stuff, Raspberry Pi stuff, just for fun on Friday nights. And then I think Tuesday, sometime morning, midday, I'm going to do some more enterprise stuff. So I've got a kind of a content schedule that I'm trying to put together and maybe even do 3 times a week. Not really sure yet, but thank you everyone for showing up for this. And I'm going to go cook some salmon with some of that firewood that you see right there. I'm going to throw that in my fire pit and cook some salmon and hang out with my peeps. So thank you very much for coming to the stream. It's pretty cool. It didn't go as smoothly as I'd like, but I don't really care too much because I'm just going to get better at it and better at recovering from crappy demo things like that. I probably should have just rebooted it the first time it didn't work. Most of these sensors have weird little glitches like that where sometimes it's like Windows style. You just reboot it and everything is fixed and good. That was the case today. So anyway, thank you. Subscribe to my stuff if you like it, and throw me ideas, especially some of you that I know are in a chat room right now that are super smart, creative people. Throw me some ideas and I'll try to come up with some stuff and maybe even drag you onto my stream if I can pull it off. Might drag you into this. So we can always do Zoom or something. But anyway, thank you, everybody.